Let us now look at isoelectronic series. What I'm referring to is the series of ions or atoms that have the same electronic configuration. That also means that they have the same number of electrons, although they may have different proton numbers. For example, let's take neon as a reference. If fluorine gains an electron, it will have the same electronic configuration as neon. Similarly, if oxygen gains 2 electrons, it will have the same electronic configuration. On the other end, if sodium and magnesium loses 1 and 2 electrons respectively, we get an electronic configuration similar to neon. Hence, O2-, F-, Ne, Na+, and Mg2+ are all isoelectronic. Within this series, how would the size compare? How the electrons are arranged does not come into play since they are all isoelectronic. The distinguishing factor is the number of protons. Remember that with more protons, the effective nuclear charge increases, hence resulting in a smaller size. Be cautious when we compare isoelectronic series. We are considering the stable ions of sodium and magnesium, which is different from the actual sodium and magnesium atoms itself. A side note, when we study the trends for isoelectronic series, we tend to leave out the noble gases in the trend. Perhaps you may say that it is smaller than F- and larger than Na+, but this is not true in reality. The reason is simply attributed to the many ways radius is being measured, and for the ions we are using ionic radius, but for neon, because it is not able to form any ionic compound, there is no ionic radius to speak of. Hence, this makes the comparison quite unfair.